Hello everyone and welcome to this video. In this video we're going to discuss about a library called Pandas, which is a Python library and which is very important, especially if you're going data science, data analysis, machine learning, natural language processing and many other applications in the field of artificial intelligence. So let's just begin. We'll name this Pandas tutorial. Okay, so first of all we'll start with a series. So a Pandas series is a one-dimensional ND array with access labels including time series. We'll first see how to create our Pandas series here. So let's first use our NumPy array. We'll name it create Pandas series. First of all, we'll see it using NumPy array. So import NumPy as np and import pandas as pd. Okay, so let's give our labels here. Labels equals to a, b and c, and we'll have a list of some kind of values. So demo list equals to, let me write 10, 20 and 100. Now if I want to make this a series, first I'll convert this list to my np array here. So this is demo underscore list, and I'll then create a series from this array demo. The data is array demo and our index will be the labels that we've defined. Okay, so if we print this, we can see that we've created a series. If we want to check out type of this one, we'll first assign this to a variable. Okay, so pandas underscore series equals to something, and we'll run this and we'll check what the if a generated variable is actually Pandas series. So yeah, it's a Pandas series here. We can also create this using a dictionary. So using a dictionary, what we can do is we can create a dictionary. Let's demo equals to, and then we'll just give our random values here. So a and its value will be 10, b and its value will be 20, and c and its value will be 100. Okay, so now what I need to do is I can define pandas underscore series. Again, I'm keeping the same name so that we won't be creating many more variables here. So we'll try to keep it simple here. So pandas dot series, and then my data is going to be dictionary underscore demo. So if I print this pandas underscore series, again I see the same form that I had saw previously, and I print the type of this one, pandas underscore series. It should be a pandas series class. Okay, now what we can do is we can also use a list. So we've already seen how to create a series using array and using a Python dictionary. Now we'll also try to create it using a series, using a list. So let's me just create this list here. I think this should be sufficient for me. So demo list equals to 10, 20 and 100, and what I'm going to do is pandas underscore series equals to pd dot series, and I'm just going to give my list here, demo list, as data. I can do data equals to demo list, or just write demo list here, it's fine. And if I print this pandas underscore series, what you'll notice is I won't have these labels here like I've defined in the previous two examples, but I'll have just the index or I'll have default labels assigned by pandas here. Now let me also check the type of this one. So this is again, or should be again, a pandas series, which is correct. Okay, So what do you think is the main difference between a Pandas series and a single column data frame? Okay, we'll come to that question later on. We'll first work out on the series first, go to the data frame, and then we'll see the difference of it. Okay, so the next part we're going to see is how can we convert a Pandas series to a list. So we've already seen how we can create a Pandas series using a list. Now if we have a Pandas series, now how can we convert that to a list? So we'll see that. Let me write this: converting a Pandas series to a list. Okay, so let me say, okay, I won't do import because I've already done import pandas as PD here, so I'll just leave it here. So let me write series demo equals to pd dot series. Okay, so I'll have maybe few variables, 10, 11, 14, 15 and 16 for now. And now if I see the type of this one, this should be a series, which is right. Now if I have to convert it into a list, what I need to do is, let me name it demo list, and what I need to do is series demo dot toList function of our series. So we just need to use toList function of our series, which will convert our variable type or our variable class to list, and then we'll also print out the variable here. Okay, so print demo, type demo list and print demo. So our values has been converted from a series to list here, and you can also see the type, the class type of our new variable demo list here, which is a list. Okay, now after this we've already seen how we can convert a list into a Pandas series. Now we're going to introduce a data frame here. So how can we convert a series to a data frame here? So converting a series to a data frame. So I'll just use my same series here called series demo. So these all have just 5 different values or 5 different rows. Now what I'm going to do is I'm going to print type of series demo first, and what I'm going to do is I'm going to convert my series demo into a data frame. So how can I do that? Just do series demo and then use a function, a series function, to underscore frame, and then your series will be converted into a data frame. So let me print my demo underscore df first, and after that let me also print the type of demo underscore df. There should be a data frame here. So as you can see, the first print statement shows that series underscore demo is a series, and after that whenever I printed demo underscore df, after converting it into data frame, my data frame seems like this. These are the index values that I have, 0, 1, 2, 3, 4, and then this is the default column value that my data frame has assigned, and we can also see that its class has been changed to data frame from series. Okay, now what I'm going to do is let's sort our pandas series. Okay, so let's sorting our pandas series. So how can we sort our pandas series? Again, I'm going to use the same series that I've defined earlier, just 5 values. Now if I want to sort this in ascending order, let me write ascending order. So if I want to sort this in ascending order, what I need to do is print, I'm just going to print it here directly. So series underscore demo dot sort underscore values function, which is given by our series class itself, and then one parameter ascending equals to true. So if I print this, now my values has been arranged in ascending order. Well, my value was previously in ascending order, as you can see. So let's change this: 16, 14, 11, maybe 12, and maybe 15. Okay, 15. Now if we run this again, we can see that our values has been arranged in ascending order. Similarly, if you want to arrange it in descending order, what you can do is you can use the same function while only the parameter changes here. So you just need to write ascending equals to false. Well, the sort values function accepts ascending here, but it does not accept the other, that is descending parameter. So you'll need to use ascending equals to true or ascending equals to false here. Okay, so as you can see, the series has been sorted into ascending and descending order here. Okay, so now we'll again go back to our data frame here. So how can we create a data frame? So we've already seen how can we convert a series to a data frame, but let's create a data frame using our list first. Okay, so I've already imported pandas, so I won't do that. So what I'll do is I'll just create a list, maybe 10, 15, 12 and 9, and I will create a data frame from this one. So pd dot data frame, pd is my pandas library which I've imported here. Okay, so pd dot data frame, and I just want to give my list variable inside and then print it. So you can see that it's a data frame here. If you want to check the type of it again, so let me write df equals to pd dot data frame. Let me print the type of demo list first. Obviously it's a list, but still let's see, and then print our df and also print the type of df here, type of df here. So as you can see, our demo list is a list. We've converted it into data frame, or we've created a new data frame from that list, and then the data frame looks like this. Again, 0, 1, 2 are index, 10, 12 and 9 are values, and then the first 0 that you see here is the default column name provided by the pandas data frame, since we have not assigned any column name in here. So yeah, this is it. And then when we check the type of df, it's again a data frame. We can not only use a one-dimensional list, but we can also use multi-dimensional list to do this. Okay, to create a data frame. So using multi-dimensional list, what value should I add? Okay, I'm going to add some Arsenal Football Club's players name. So Gabriel Jesus, and then his squad number is 10. Again, another player which is Martin Odegaard, and his squad number is 8. And another player, Gabriel Martinelli, whose squad number is 11. So if you are a big football fan or an Arsenal fan, you can easily relate to these data. Okay, so let me create a data frame from this one. So pd dot data frame, I just need to give my demo list here. Again, if you want to check the type of this one, you can simply print the type of demo list first. It's a two-dimensional list here. So okay, and then I'll print my df, and also okay, we'll first print the type of df, and then after that we'll print df here. So as you can see, I had a list previously called a demo list, from which I created a new data frame called df, and then since I had multiple values in a single index of this outer list, so what it does is it inserts it into one particular row. So again, 0, 1, 2 are index, and 0 and 1 are the default column names generated by the data frame itself. Okay, so this is how you create a data frame using a multi-dimensional list. Well, you can also do it using a dictionary, which we are going to do here. So using dictionary, what you need to do is I'll just create a demo dictionary. Again, I'll use the same example here. So for this one, what you do is you first define your column name, and after that you define your values here. So maybe Jesus, Odegaard, and Martinelli, and after that one you again have a second column where you'll first assign your column name. I'll give it number, and after that you'll again create a list and then put the values, or here I've inserted the squad numbers here. So now again I'll do the same thing. I'll just copy this. Okay, so pd equals to df equals to pd dot data frame. I'll give a demo dict here. If I want to check the type of this, what I can do is print type demo underscore dict here, and then create a data frame using demo dict, and then print the type of the data frame, and then again print the entire data frame here. So you can see, as we had given our own column names or labels to the data frame, so instead of 0 and 1, the data frame consists of the column names or the labels provided by us, and the values are somewhat similar. Okay, so this is how you create a dictionary into your data frame. Okay, so now we move to another example. Let's say, how can we add another column to an existing data frame? Okay, so we already know how we can create a data frame. Let me use this same data here. So we have name and number. If I print df here, we can see that we have name and number. Now if we want to add a new column to this one, what I need to do is I simply need to introduce a new column name here. So let me say this is my goals, since the season has already started. Again, if you're a football fan, you can kind of relate to this. So yeah, the season has already started, and then among these three players, Gabriel Jesus has scored 2 goals, Odegaard has scored none, and then Martinelli has scored 2 goals up until now. So if I add this one, what happens is now a new column has been added to an existing data frame here, which is called goals, and then their respective values. So this is how you add columns to a data frame. Now what we can do is, you can also append one Panda data frame or one data frame to another data frame. So how do we do this? Suppose, let's say I have a data frame with the same value. Let me call this df1. Let me remove this print statement, and then what I'm going to do is I'll add some more values here. So demo underscore dict1 equals to, again I'll just copy these values and then create new data within them. So the name is going to be, again, more players, so the name is going to be Saka, and okay, who else is Zaka again, and White. So he's Ben White, Granit Xhaka, and then Bukayo Saka. So their squad numbers are 7, 34 and 4. Okay, so now what I need to do is again, I'm going to create a new data frame here. So df1 and df2 are 2 separate data frames, as you can see. So now what I want to do is append one data frame to the other. So basically what I want to do is I want to append df2 to df1. So for that I just need to use append function of the data frame, and then what I can do is I can do df2, so df1 dot append df2, and if I print this, you can see that I have a combined value. Okay, so did I miss something? Sorry. So yeah, df2 should have dict2, and if I print this, so yeah, I have Jesus, Odegaard, Martinelli, and then from the second data frame, Saka, Zaka, and White. Again, we have the names and numbers as we had assigned, but one weird thing that you might see here is the index values that we have. So 0, 1, 2, the first three index are from the first data frame, and then the last 3 index are from the last data frame or the second data frame that we have, but these index are not arranged here. We'll do that, but we'll do that after some time here. Okay, before that, what I want to do is I want to sort my data frame based on the kit number that I have. Okay, kit number. Okay, okay, so based on the kit number, what I need to do for this one is, since I already have a data frame 1, okay, sorry, so I haven't appended this. So what I need to do is df1 equal to df1 dot append df2. If I print df1, I already have this appended data frame. So now what I'm going to do is I'm going to sort this data frame based on my number here. So df1, again use a function called sort values. What do you want to sort it based on? So by this is going to be sorted based on my number. And again, if you would like an ascending sort or descending sort, just give your values here. So I'll write ascending equals to true. So what should happen here is the order of players that we have should be sorted based on these numbers. So the first data should be White, second should be Shaka, Odegaard, Jesus, Martinelli, and then Xhaka. We'll see if it happens or not. So as you can see, based on the kit numbers, the entire data frame is sorted here. Again, the index looks very random, but we'll work on that later on. We'll also try the opposite of this one. So just ascending equals to false, which means we're going to sort this in another order. And as you see, the highest number is first one, and then the lowest kit number is on the last row here. Again, the indexes are all messed up. We'll organize that later on. So now if we have a data frame, how can we export this data frame to a CSV file? So for that, we already have a data frame called df1. Again, I'll print this out. So it's just in random order. So to export this data frame into a CSV file, what I just need to do is df1.to_CSV, which is again a function provided by your data frame, and then you just need to give a name here, just call arsenal.csv, and then we'll be done. Let's see. Okay, it's imported. We'll check if our if our data is actually imported or not. So copy link. Okay, so we have arsenal.csv here. If we want to open this, we can see a name, number. At first we have index 012, and then the names of the players, and then the kit numbers that we have. So we successfully exported our data frame to a CSV file. Okay, so after this, we'll work with our data frame indexes here. We'll try a simple example. We'll first let me just create take this value and then create a data frame out of this one. So we have df1 here as a single data frame. What I want to do is I just want to select one column here. So select only name column from here. So for that, what I need to do is, let me just write print, or I'll just write df1 and then just hit name here, and then you'll see that only the name pops up here. Again, if you want to print only the number here, again the number pops here. We'll do something different. We'll only select our second row here. Okay, we'll only select our second row here. So how can we do that? Just say df1, and we'll use an ilog function here. So ilog, and then since we need a second index variable, so this is how we represent it, and then we'll print our second value, which is Odegaard, and then the kit number is 8 here. Also, what we can do is we can select the top two rows that we have. So for that one, again df1.ilog, the format is going to change here a little. So from 0, the maximum limit is 2, but sorry, the maximum index that we want to include is 2, but when we give 2, it takes one value lower than that. So if we print this, again we have just 2 rows. If we only want to print 1 row here, so what we can do is, if we only want to print the top row here, just set 1, and then we have top row here. Or if you want to print all 3, set 3, and then and then you can work out with this. Okay. So now what we want to do is, since we've already exported our data frame into a CSV, what we want to do is we also want to read a CSV and then convert it into our data frame here. So I'll just import my pandas once again. It's not actually important, but let me do this. So let me write data equals to pd dot read CSV. You have this read CSV function, and then I have arsenal dot CSV file in my folder. So I'll just read that, and if I sorry, so I don't have arsenal.csv here. Sorry, my spelling was all wrong. So okay, I do have arsenal.csv, but what happened here? I do have arsenal, so it's arsnel.csv. okay, so let me just copy the name from there directly and then paste it. Okay, so if I import this and then print my data here, so I have a new index added to this data frame. I also have my old index and then my player name and then my kit number here. Okay, so the old index is being brought here as a new column here, which we can also remove based on our requirement or something. Okay, so this is how basically you read a data frame. Well, sometimes you might get your encoding error while reading a CSV file. So for that, you basically need to include your encoding format just as a parameter here, and then you'll be set. And if your file is since your file is comma separated, we don't need to mention our delimiter here. But if your file is tab separated or something like that, you also need to give your delimiter here. And then based on what maybe it could be a new line, maybe it could be a new tab, new space, or 4 space, 5 space, you can read your CSV file from here. Okay, so yeah, this is how you do it. Now after that, what I want to do is I want to perform some aggregations on this data. So to keep things simple, I'm really using this same data frame here. So let me create this data frame again. I won't use this data because it has this unwanted column which I should remove. I'll teach you how to remove that, but again we'll come back to it later on. And what I want to do is I also want to include goals here, goals of each players. So goals, and now my striker Gabriel Jesus has scored 2 goals this season, Odegaard 0, and then Martinelli has scored again 2 goals. So now what I want to do is, if I print tf1, again you have this data frame. Now I want to perform some aggregations, basically 3 aggregations. Okay, so the first aggregation is the minimum value. So what I want to do here is print out the minimum number of the lowest goal that has been scored by any player here. So number dot min, which will give you the lowest. Sorry, I want to do it based on goals. Okay, so which will give you the minimum value among these 3 values here. So again, if I want to print the maximum values, what I can do is, so goals dot max, it should give me 2 goals. We can also do the sum of these goals. Okay, so the total of 3 players have scored 4 goals. Sorry, not here. I scored a total of 4 goals here. Okay, so this is how you do basic aggregations. So I've just shown you min, max, and sum aggregation here. We can also do our group by aggregations here. Okay, so group by aggregations. So for that one, what I want to do is I want to use this same data, but I want to add some more rows to this one. So let me write Saka and Xhaka and Ben White here, and then the get numbers respectively are Saka has 7, Xhaka has 34, and then White has 4, and then they have also scored some goals. So Saka has scored 1 goal, Xhaka has scored 1 goal, and then Benjamin White has scored 0 goal. what I want to do is I also want to add one more column to this one, which is which will be our position, which we'll keep using later on too. So my first value, Jesus, is a forward, Odegaard is a midfielder, Martinelli is a forward, Saka is again a forward, Xhaka is a midfielder, and my Ben White is defender. Okay, so I've added these. Now what I want to do is I want to create a data frame from this one. Again, I can use the same syntax. So I have name, number, goals, and position. Okay, so what I want to find out is first of all, I want to find out the total number of goals scored by each position here. So if I want to know how many goals my forward, midfielder, and defender has scored in total, what I can do for that one is df1, and I'm basically comparing this with two positions. The first position will be, sorry, the first parameter will be my position. My second parameter will be goals. Let me just wrap this up into another list here, goals, and what I'll do is I'll do group by. So what are we going to group this by? We're going to group this by position and then hit sum here. So if I see my defender among these data has scored 0 goals, my forward has scored 5 goals. Is this correct? So Jesus is a forward, 2 goals, Martinelli is a forward, 1 goal, and Saka is a forward, Martinelli is a forward, 2 goal, and Saka is a forward, 1 goal, which is 5 goals, and my midfielder Xhaka has scored only 1 goal. So yeah, you can also do this group by aggregations based on your data. Again, if I want to see the maximum of every position that I have, I can simply do this. So my defender has scored a max of 0 goals, forward has scored a max of 2 goals, and then the midfielder has scored a max of 1 goals here. And then I can also do a minimum. Again, the minimum will be the same because both of my I'll just enter this and see. Again, my defender has scored a minimum of 0. My forward has scored a minimum of 1 goals because each and every forward has a goal. The player Bukayo Saka has the lowest, which is only 1 goal, and my midfielders, there are 2 midfielders. One has scored 1 and then the other has not scored, so it should be 0 goal here. So this is how you do group by aggregations too. Okay, and then you can also combine, you can also apply group by aggregations, or like you can also apply group by with 2 different aggregations here. So I'll just show you how you do that. Apply group by with 2 different aggregations. So for this one, what you can do is, so df1 dot group by, you'll want to group this based on your position, and then what you want to aggregate is you want to aggregate your goals, and basically you want to add, okay, now these parameters can be anything, but I've added a mean, a sum, and a median here. Okay, np dot median. So if I print this, so my defender has a mean of 0 goals, they have no goals at all, they have sum of 0 goals, and then the median of 0 goal. My forward has a mean of 1.67 goals, a total sum of 5 goals, and then the median of 2 goals. My midfielder has a mean of 0.5 goals, the sum of 1 goals, and then the median of 0.5 goals. Okay, so this is how you can apply group by with multiple aggregations here. You can add as many aggregations as you want after this too. Okay, so now what we want to do is we want to find out our missing values in our data frame. So finding out missing values in data frame. For this one, I'll use my same data frame here that I had created earlier, but I'll change a few values so that we can find our missing values. So So suppose we say our player Granit Xhaka has no kit number, or the kit number value is actually missing, and then our player Ben White has no position, let's say. Okay, so Ben White, or like maybe we can say Martin Odegaard has no position here, so it can be none. Okay, so now if we create a data frame here and then print this out, what we'll see is we'll see a data frame, but there are null values here. So this is an n, and then we have a null value here. So let me check how many null values are actually in this data frame. Since it's a small data frame, so we can basically say there are two different columns that has null values here. But in case of a very large data frame, going through it manually is a tedious work, so we can just use this isNA function and then do the sum of it, and then we can see so that there are 0 null values in name, 1 null values in number, which is this one, again 0 null values in goals, and then 1 null values in position. So now how can we remove these null values? Okay, so we'll work on removing null values from here. So for that one, what I can simply do is df1 dot drop NA, and then I'll do in place equals to true, which actually does not mess up our index here. And basically if I print this out, so I also need to print this out. So if I print this out, what will I see? Okay, so it's done. Okay, so this is an aggregate function, and then if I print df1, now we see that there are no rows with null value. So basically one row with null value, the row number 1 is removed, and then the other row, which is row number 4, or like index number 4 is also removed, and then we only have 4 rows out of 6 rows. So yeah, this is how you can remove your rows containing null values in any column from the data frame. We can also find out, so like whenever you're working with a very large data set, we can also point out the exact index or the exact row number where you have your null values there. Okay, so let me just redo this again. Let me just use the same thing again. So I have this data frame with null values. So what I can do is I can iterate over my data frame to find my null values. So for that one, for index and data in df1, so now if pd dot isNA, and okay, what do I want to find my null value based on? So I'll just use data here. Okay, nothing else, just a single row here, nothing else. And what I want to do is I want to print my position or my row number, which has the null values, and then this row number is going to be my index, and I'll also print my data here, where my row value actually occurs. Okay, so data here, and let me just write data and my, okay, what do we want to paste? Okay, so I want to basically find null values based on my number column. So if I do name here, what I can find out is, okay, so I missed something here. Sorry, comma, there's no comma here. Okay, print row number and my index, comma, and my data equals to, and my data name. So this should be correct. Oh, sorry. So okay, df1 dot iter rows. So I want to iterate over the rows of my data frame, and I can see that based on my number, my row number 4, Granit Xhaka, has a null value here. If I just want to base this on nothing here, we'll see what happens. Okay, so we should give some value here, or some column name here. Okay, so based on that only we can do this, or we cannot pass our entire data frame here, but we actually need to pass our series here. Series means just one column here. Okay, so we can also do this based on our position. So if we see row number 1 Odegaard has a null value. Okay, so moving on, what we want to do is we want to reindex our data frame. Reindexing basically means the weird index that we had seen earlier. Let me go back to that position again where we had that. Okay, so yeah, we had this here. Let me just copy these statements, and then we'll see how our indexing is all messed up. So let me print df1. I have df1 with 3 players, df2 with 3 players, and then I've appended my df1 with df2, and then printed it. So yeah, it has all kind of weird index here. So for that one, what I need to do is what I want to do is I want to have an index. So basically I want to give my own index. 1 2 3 4 5. I have 6 players, so 6 players. And what I want to do is, let me just use my reindexing function. So df1 dot reindex, and then I want to give my new index values here. And then if I print my what happened here? I cannot reindex on an axis with duplicate labels. Oh, okay, so I first want to arrange this, and then I want to use this. Okay, so what I'm going to do is I'm just going to use 3 index here for now. So 1 2 3. Let's not use reindex, but let's create a data frame based on the demo dict1, and then I want to provide my own index instead of the index provided by the data frame itself. So index equals to index. If I print df1, I can see 1 2 3 index, and my index doesn't start from 0, but now it starts with 1. Now what reindexing actually means is I want to shuffle down the row number based on my interest. So let me say index equals to, I'll first show my second row data first, and then first row data, and then third row data. So what I can do is df1 dot reindex, and if I hit index, what it does is it reindexes my data, or shuffles my data based on the order that I have provided. We can also go back and then do the thing that we are trying to do, basically reset our index, and then have a standard 0 1 2 3 4 5 6 here. So for that one, I'm going to copy this. So basically I want to reset my index here. So reset my index, and okay, if I print df1, I have these all kind of weird indexes here. So without appending, what I want to do is I basically, okay, so if I append, I have that problem. But if I don't append and use a concat function, so final df equals to pd.concat, I can also concatenate data frames using my concat function instead of using my append function. So df1 df2, and if I give ignore index equals to true, now if I print my final df, you'll see that my indexes are all arranged, which was not the case when I used my append function here. Okay, so this is how you reset your index using concatenation function, and then you can also do the same after sorting your values. So I'll just do okay, so df1 dot sort, okay, so df1 equals to df1 dot sort underscore values. So I'm going to sort this based on my numbers here, based on my numbers here. Okay, number here, and then I'll say ascending equals to true. And if I print this, you'll see that my index is again messed up. So yeah, if I want to reset this, what I can do is df1 equal to df1 dot reset underscore index, and then drop equals to true. So if I print df1 now, you'll see that the rows are not changed, but my index has been reset, and then it has been regenerated here. Okay, so yeah, this is how you reset your index. Now one interesting thing I'm going to show you is perform binning on categorical values. So let's say you have a range of data, or like a particular set of data, maybe 5 columns, or maybe maybe 5 distinct categories of data, or 6 distinct category of data, and then you basically want to group them based on their maybe their order or something like that. We'll basically try to group here based on our players' position. So how high they play, or how low they play, or how like in the medium they play. So I have this data frame that consists of, let me just write demo underscore df1. So I have this data frame that consists of my players, 6 players, and then their positions here. So now what I'm going to do is if my players are playing forward position, I want to basically add a new variable, or add a new column, and then adjust their values maybe like they're playing higher. If they are in midfield, they're playing medium, and if they are in defense, they're playing low. Or also I can arrange it based on the goals they have scored. If they have scored maybe top goals, maybe 4 goals or 5 goals, I'll say like they have higher number of goals. If they've scored lowest goals, they have low goals, and then if they are in the middle, they have scored medium goals. So how do we do that? Let's see. Demo underscore df1, I'll say goals underscore bin, since I'm doing binning here. And for that one, I need to use a cut function, pt.cut function, and my data frame demo underscore df1, and I'm doing this based on goals. I want to basically categorize them into 3 different categories, from low, medium, and high, and then I'll give my own labels here. So these labels can be low, medium, and high. And now if I print my demo underscore df1, what I can labels equals to low, medium, and high. And now if I print, so my player who has scored 4 goals has been categorized to high. My player who has scored 3 goals has been categorized to high. 2 goals is medium, 1 goal is low, and then 1 goal is low, and then 1 goal is low again. So if I want to do this maybe just into 2 distinct categories, low and high, I can also use this. And then if we see 4 and 3 are categorized as low, and then anything lower than 2 is categorized to 4 and 3 are categorized to high, and then anything lower than that are categorized to low. So such kind of transformation can be very important, especially if you're doing data analysis. If you want to categorize your continuous data that you have based on certain categories that you want to put in. So yeah, you can basically perform your binning here. So after this, what I want to do is I want to find out which of my columns are actually my categorical columns, and then which of my columns are my numerical columns. Okay, so how do we do that? Especially I'll do it for the numerical columns. So what I can do is I can say all columns equals to list, and then demo underscore df1 dot columns. If I just print this, I'll get my all columns name, CLUMNS, lmns. Okay, so I'll get my all columns name, and then from this one I can separate numerical columns based on a very simple function. Numerical columns equals to list demo underscore df1 dot underscore get underscore numeric underscore data, and then I can and then I can just write dot columns columns, and then if I print my numerical columns, you can see that my numerical columns are just the numbers and goals here. The rest of it are all categorical. Maybe they have text in them, or maybe they have string categorical values in them. So this is how you find out which of your columns are numerical, and then which of your columns are categorical. What we can do is we can also assign or like we can also convert our categorical data to numeric data. So for that we are going to use a function called cat.codes. So how do we do this? Okay, we already have our demo underscore df1 here. So we have okay, we'll take this position here and then convert it into our numerical value. So this is basically categorical value. We'll convert this into a numerical value. Now how we can do this is let me say demo underscore df1 position position equals to demo underscore df1 position dot as type, and then this will be a category type. So this is a categorical value that I have here, and after this I want to convert this into numerical value. Maybe I'll add my new column here, postcodes equals to demo underscore df1, so position dot cat dot codes, and then if I print my demo underscore df1, what happens is I have a new column here which is a position code, and then I've converted my defense to a 0 numeric value, midfielder to forward to 1 numeric value, and then midfielder to 2 numeric values here. Okay, so yeah, this is how you convert your categorical data into a numerical data. So okay, we've done a lot of things in pandas here, so I think you understand this. If you have any problems, or like if you face any problems, please let me know in the comment section. I'll try to help you out and go through this. It will be very important if you're especially starting to go inside data science, or like if you are practicing data science and then don't have a very good grasp on pandas. Well, I hope the tutorial can be very useful to you. Okay, so yeah, only this much for today. I'll see you in the next video. Thank you.